Alright guys, welcome to my channel, and please click on the subscribe button if you have not subscribed to the channel, and please also like the video at the end. Thank you. So today we are going to look at multiple linear regression, and in case you've not watched the earlier video on simple linear regression, please kindly watch the video, because I explained some concept that will help you understand what exactly we are doing. So without wasting time, let's dive forward into what we're supposed to do. So essentially what multiple linear regression implies is that you have more than one variable affecting another variable. So let's say you have that maybe you're selling jackets, and the quantity you sell is dependent on maybe the price you're selling it, which is number one variable, and number two, maybe the average daily temperature. That's number two. That's number one. Sorry, the jacket you're selling is dependent on the price you're selling it, which is number one variable, and second, maybe the average daily temperature. Within a maybe average daily temperature in a time period. Maybe that's variable number two. So the quantity of your sales is dependent on the price and the daily temperature, average daily temperature reading. So you have that two variables that are affecting the outcome of another variable. So it could be 2, it could be 3, it could be 4. So usually this is the case in real life scenarios where you have a lot of factors affecting the outcome that you're trying to optimize. So we still used our linear regression, but like I explained before, linear regression is not a robust model to give you accurate prediction, but it's still useful to maybe explain the concepts, or maybe introduce you to the concepts of prediction and forecast. So if you look at this formula, you can see that it's similar to the one we use for simple linear regression, which is that y, which is our dependent variable, is equal to the slope. We can use anything to denote the slope. Last time I used m times x, mx, plus the intercepts. So we can use a constant, or we can type intercept, or we can use c to represent intercepts. So we have that dependent variable is dependent on the slope multiplied by the independent variable, in this case maybe the price, then plus the intercept, and you know what intercept is, you know what slope is. So but in this case we have more than one x, so we have x1 and have x2, and both will have their own slopes. So we have that we use a to denote slope for x1, maybe price, then we use b to denote slope for the average daily temperature, and then the c for the intercept. So you just have to plug in the numbers, and then Excel will give you all this, so you can put it in and make your prediction. Right. So let's look at this typical case where we have that. So let's say that this is a delivery company, and the delay in minutes to deliver maybe your what they are selling, or what they are sending to your customer. We have factors that are affecting it. Number one, you have the traffic congestion, which they denoted probably in minutes, and then you have the volume of pallets that they are transporting, and then you also have the average raindrops, maybe if it's raining or if it's not raining. So all these factors will contribute to cause a delay in minutes in delivering their product to wherever they are delivering it to. So now what we are trying to find out is what is going to be the delay for maybe when the volume of pallet is 26, and the congestion is 10. So we just want to make a prediction depending on all these other variables. So what we need to do is to find out, to generate an equation like this, where we can plug in the values to give us the prediction. So now that we have a typical case of like a real case of making a prediction based on different parameters that are affecting a particular variable, in this case our dependent variable. So like I said earlier on, here the delay in minutes is the the dependent variable, and you can see that you have three other factors that are affecting it, which in this case is our independent variables. Now you have congestion, you have volume of pallets, and you have average raindrops. Now you want to do a regression analysis. You want to generate a model. You want to generate this equation that you can use to make predictions. Now, so you have these three. They've given you values for the three different independent variables. Now you're supposed to make a prediction for the delay. So if you have all these variables, what is going to be the delay? Now, how do you do it? So we have a tool in Excel, the regression ToolPak, which helps us to solve it without having to go through manually doing the calculation, because you can actually do it manually though. Yes. So how do you do it? So what you do is you come to data, and then you have a data analysis here, and then you just find regression and click on it. Now, peradventure you don't have this in your your PC, you come to files, and then come to options, and in the options you click on add-ins, and then you click on go, and then you see the analysis toolpak here. You just tick it. If it's not ticked, you tick it, and then okay, and then it will automatically appear on your toolbar. So how do we do it? Then you click on analysis, and then you go to regression, and you click on OK, and it will tell you to input your Y range, to input your X range, and then your output range. So these are the three different inputs you need to put here. So our Y range, like we have agreed, our Y range is our dependent variable. So in this case, it's our delay in minutes. Now you select the Y range, and then you know that I included the label here, which doesn't have any number, which is just word. So ensure that you tick this label so that it doesn't bring in errors. Right. So it will ask us what is our S range. So we have three different X here. You have this one, you have this one, you have this one. So we have three columns. So all you need to do is just click here and drag it around and cover all those boxes, and then yeah, then tell you the output range. So that's in case you want to, if you wanted to create a new Excel file, a new workbook, you can click on this. If you wanted to create a new sheet, maybe another sheet here, it will put it in that sheet. You can click on this, but then I would just want it to be in the same sheet, so you just click on here and then select the cell where you want it to put it. Let me just put it here. Yep. So when you're done with this, then you click on OK. Every other thing remains the same. Oh, what did I do? So let's do it again. Then this is our Y range. Our Y range is this, right? Then our X range, our S range is this, and then every other thing is the same. Click on OK. Yeah, so we have our results, and it might look very overwhelming, a lot of things going on in the results, and you don't need to bother yourself with a lot of other variables. We just need a few things here to use it to make our build our model, to build our equation. But first of all, the numbers you need to be interested in is, first of all, the R square. Not that it's so interesting, so important anyway, but then it's like it gives you an idea of how good your model is, how it has been able to explain what is happening in this table. The model I mean here is this equation. How good is has it been in explaining the variability in the different entries in the table, different rows, or different rows, like different entries in the column. How has it been able to explain it? Now that's what the R square stands for, and it ranges between 0 and 1. So the higher it is, the good your model in quote is. So you can see that we have 98%. So which implies that our model is kind of good. Of course, this is a hypothetical data, so it's kind of corresponding. Yeah. So but ideally you might not have up to this in you have real cases, but then yeah, so you can see that you have 0.98, which stands for 98%. So this our model is a very good one. So adjusted R is just in case you have very large factors affecting your Y or your dependent variable, may not, the R square might not be able to tell you how good your model is, so you might have to go to use the adjusted R. But in this case, we just have 3 parameters here, so it doesn't really so R square is enough to explain our model. Then the other thing you need to look out for, right? These are our main guys. The intercepts, the congestion. These are our x's. Yeah, not that kind of axis, So these are our x1, these are x1, these are x2, these are x3, So they have their own slopes. So you have slope for x1, which is this, slope for volume of pallets, which is this. We have, so in this case, this b is going to be this, and then of course we have an x3, and the slope is going to be this for average raindrops. Yeah. So if you don't understand what I mean by slope, please try and watch my previous video on simple linear regression. I explained everything about it. So yeah. Now another thing you need to look out for is the p-values. This is very important because it tells you how significant the parameter is in affecting or the outcome of what we are predicting, or what is depending on it. So you can see we have for the congestion, you have the p-value is 1.14 exponent minus 0.006 exponent minus 6, so that's like 0.0000 into 5 and into 6, yeah, 0.0000, yeah, whatever. Yeah, so but your p-value has to be less than 0.05 if you have a 95% confidence interval. So you can see that usually it's usually 95% confidence interval, for most statistical analysis. You can have yeah, usually most 95%. So yeah, so just know that your p-value has to be less than 0.05 for you to trust that this particular congestion really affects the delay. If it's more than 0.05, then the impact on the delay might not be significant enough for us to like use it to make our prediction. So that's what it means. So p-value has to be less than 0.05. You can see that for congestion it is way less, so you can trust this. For volume of pallet, you can see that it is 0.03, which is still less than 0.05, so yeah, it affects. Then for average raindrops, you can see that it is 0.17, which is more than 0.05, so we cannot use this as a parameter, or we cannot include it in what we are using to create our model, because what it's going to do is going to bring noise. It's going to bring noise into our data, into our model. So for us to exclude this, for us to remove that noise in our model, we have to do this analysis again. Now when we are doing it, we're going to exclude average raindrops in our X range of data. So what do? We go back here, go to data, and click on data analysis, and you click on regression, and then okay. So we have to remove all this and then do it afresh. Yeah. So for input Y range, it still remains the same. For input X range, you're going to use just the 2 columns. You're going to exclude the raindrops, average raindrops in your in your data. So the output range, let's put it down here. Oh, what did I do? So your X range is your output range. Let's put it down here. Let's click on OK. Yeah, write the data. So you can see now that you have a new table, with now in this case we don't have the average raindrops anymore, so you have just the congestion and the volume of pallet. So you can see that our p-values, right? Our p-values, in fact, it has even gotten lesser and lesser. You can see that you have the exponent is minus 0.07. So the accuracy in providing us a good outcome in our model is increasing when this value is reducing. So it means that we are having a more accurate model, or a more realistic model, as these values decrease. So you can see that this one that was 0.03 is now 0.02, so it has gone down. So yeah, so we have removed the noise from the average raindrops. So what do we now do to predict for this entry? We need to have a value here. So we just go to our formula and impute we impute all the figures we have here. So we have our intercepts, which is the y-intercept, that is this, this. We have our congestion, which is this, the slope is this, the slope for this is this. So just come here, right, and then we say equal to start the formula. Then you say, remember our formula. So this y is equal to, y is our delay, is equal to, what is a is the slope of the first independent variable. In this case, this slope is going to be this, yeah, then multiplied by x1, which is the x1, which is what is given to us. What am I doing? So the slope multiplied by the x1, which is this, that is the congestion, right? Then this plus x2, or slope for x2, which is going to be this, multiplied by our x2, which is now going to be the volume given to us, which is this. Then you add the intercepts as we did here, so just come here and then select the intercepts plus the intercepts, and then enter, and then you can see it has given us the predicted delay if the congestion is 62, if the volume of pellets is 26, and this has no significance, as you've seen, because of their p-value. So it has no significance, so we did not include it. So only these two variables are enough to make a prediction based on this our model. So yeah, and we have done a multiple regression analysis, to predict the delay, based on historical data. So if you have any questions, please drop it in the comment section. In case you have issues with this formula, you don't understand what I was in here, try and watch my first video on simple linear regression. It will give you clarity on how this formula is being arrived at. So yep, thank you.